Alright, in this video we begin target 8a, properties of rationals. 18. Determine the interval in which the graph is decreasing. So when it means to decrease, that means from left to right you are going down. So just by looking at this graph, I'm going to zoom in more. Okay, so we start, oh my bad. Alright, so we start from here, left to right. So we're from here, meaning at this point, as we're going more towards the right, what is happening to my y's? Well, my y's are going all the way down. They are decreasing. Where are they decreasing from? Well, if we started from here at the edge, technically the graph is still going to the left. Still. Oh, what? Oh, okay, my bad. Wow, lately one of has been very jumpy lately. Okay. So we are starting from negative infinity, hence this position here. So parentheses, negative infinity, comma, and we're decreasing up until what point? We keep going here. See here, we never cross this line. So we look at this x value, and it turns out to be -2. So we go from -2. Since we never touch it, because it's an asymptote, we have to use parentheses. But then from there, after -2, the next point that we move on after -2 turns out to be here on top. So that means we just move forward. In that case, we do a U for union, parentheses, and then we just look at it from left to right. What's happening to the graph? It's going down. So therefore, we say from -2, comma, when does it start to go down? So it starts to decrease, 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 stops, increase, 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 increase. When did it start to decrease? From -2, and it stopped at this point. What is the x value at that point? Well, this one's more obvious. It's at the center, so it's 0. Then we'll do a bracket. Why we're doing a bracket is because we could physically touch that point. This point does exist on the graph. Parentheses means we don't ever touch that point, hence the asymptotes. So afterwards, it starts to increase. Therefore, we do not write the interval because we only want the decreasing interval. Alright, so then after this asymptote, we are jumped back to here, over here, and if you can see here, it also starts to increase. So we don't have to write that interval because we only want decreasing. So the interval is from -infinity to -2, union -2 to 0. Alright, 19. Find the sum. When you're dealing with finding out the sum, what you want is the denominators to be the same. So you want 8x to equal 4x squared. They're not the same in this case. A lot of times you could make them the same. You could multiply 4x squared and you can multiply 8x to both sides. Then you get 32x cubed is equal to 32x cubed. In this case, that's perfectly fine. But when it comes to this, it's a little bit of a faster way here. If I have 8x and I want it to be the same thing as 4x squared, this 8x is technically missing just an extra x because x squared is denoted as x and x. So I could just multiply both sides by x. And over here with the 4, it's just I just need to multiply by 2. Now I have 8x squared, and that will be equal to 8x squared as well. So that's when I'm going to be multiplying to the top and bottom and to the top and bottom of those fractions. So I'm going to just erase this right here for extra room. So equals the first fraction, 7 over 8x, and I'm going to multiply this by x on the top and x on the bottom. Next one, it's going to be plus 5 over 4x squared. I'm going to multiply this one by 2 from the top and 2 from the bottom. Then just distribute. That becomes 7x over 8x squared plus, then distribute again, 10 over 8x squared. Now that the denominator are finally the same, I could just combine them. So over, add the fractions, 8x squared, 7x plus 10. They are not the same term, so I cannot combine them whatsoever. So I just put an addition, and there you go. I cannot factor anything, and I cannot cancel out anything else at this point. So this will be my final answer. Okay, wanna randomly stopped. Alright, I'm gonna just finish up this problem quick. 7x plus 8x, that'll be 10 over 8x squared, and that'll be left with 7x plus 10 over 8x squared with the final answer. Okay, next one. Find the product. So when you're finding a product, think of this as 3x minus 2 all over 5x plus 20 times this polynomial over 1. First things first, always factor. 3x minus 2. That cannot be factored anymore, so I'll just write 3x minus 2 over the 5x plus 20. I could use a GCF of 5. This has a factor of 5. 20 has a factor of 5. So I take out 5 here, parentheses. So then I'm dividing everything by 5. 5 here will cancel, leaving you with x plus 20 over 5 will be 4 times. Alright, then here it's a polynomial, so I'm going to do 8 times c. 1 times negative 8 gives me negative 8. What are the factors of negative 8 that will add up to 2? That'll be 4, negative 2. Then divide by your a, which that'll be 1. So I'm left with x plus 4, parentheses, x minus 2, all over 1. Next step is to cancel whatever have in common on top and bottom. X plus 4 cancels. Nothing else. Now you have to do, just multiply. 3x minus 2. And then you just put x minus 2 all over 5 times 1. Leaves you with a 5. Final answer. Alright, 21. What I prefer to do for 21 sometimes is multiply both sides by x minus 3. Multiply both sides by x minus 3. And then they cancel, leaving you with just the top to work with. Other people like to also cross multiply. Just letting you know, you could cross multiply here, leaving you with 7x times x minus 3 is equal to, parentheses, x minus 3 times 2x plus 15. And then you want to get rid of, maybe let's go with the x minus 3. So you divide both sides by x minus 3. X minus 3's will cancel. Then you have 7x is equal to 2x plus 15. So they both end up the same way. Then from here, you want to have x by itself, so I'm going to subtract 2x to both sides, leaving you with 5x is equal to 15. Then you need to divide both sides by 5 to get rid of the 5 located here. I'm writing this notation because, as you can see, I ran out of space, so the 5's will cancel, and then you're left with x is equal to 15 divided by 5 will be 3. But according to this though, whatever's in the denominator, I always like to figure out what can x not equal. So I set the denominator always equal to 0, and that's what it cannot equal. So x cannot equal 3. And then because of that, since if you see here, they match, x equals 3 turns out to be a extraneous solution. So it's not an answer. Since that my only answer turned out to be extraneous, that turns out to be a no solution. Why does that matter? Well, if I plug in 3 in for here, I'm going to have, let's go with 7, 3 over 3 minus 3 is equal to 2, 3 plus 15 over 3 minus 3. I end up getting 21 over 0 is equal to 21 over 0. When it's 21 over 0, they match. That's great. But the downside is 0 can never be in the denominator because that leads to undefined. Hence, extraneous. So we could never have 0 in the denominator. The shortcut, always solve for the denominator equal to 0 and just know that is the number we cannot have as a solution. So I'm going to zoom out a bit so you guys can see the overall work. Alright, number 2. Oh, that was a little bit too much of a skip. Alright, first I'm gonna factor this one right here. And I guess this one I'm going to be doing multiple things at the same time. First, I'm going to combine these terms together by the first fraction, which is 1 over x minus 6. I'm going to make that multiply it by x minus 2 over x minus 2 plus x over x minus 2. I'm going to multiply that fraction by x minus 6. That way we could have the same denominators. Remember, the goal is to get a fraction equal to a fraction. Here we have two fractions equal to one fraction. So therefore we need to condense, we need to simplify this addition right here. Is equal to 4 over, how to factor. This one turns out to be, well, what are the factors of 12? That give you -8. That's going to be -6, -2. Divide them by 1. So nothing changes. So we're left with x minus 6 times x minus, well, that's messed up, x minus 2. Alright, erasing this right here. Alright, then after this step, I will be looking for what could x not equal. So x cannot equal, well, -6, so turn the opposite of that, that'll be 6. X minus 2, that means it'll be 2. Alright, here, it's the same here, so we don't have to worry about it. There, it's the same, that's the same, and that's the same. So my only options that x cannot equal is +6 and +2. Then I'm going to just combine. This should be here, leaving me with x minus 2 plus x squared, I distributed, minus 6x. You see here, now that they have the same denominator, I'm going to just already combine it and make it over x minus 6 times x minus 2 is equal to 4 over x minus 6 times x minus 2. And this problem now gets very similar to problem, scroll up a bit, right here, my bad, right here, went too far. This problem here, you see here, if it was in the denominator, wow, I don't know what's up today. Okay, see how here, where was I? Okay, here in the denominator, you had the x minus 3's both in the bottom, and they ended up both canceling out. Okay, that will always happen. If it's both in the bottom, and there's an equal sign in between them, they will cancel out. Why? Because you're going to multiply both sides by x minus 3, and they both cancel out. And so we're going to be doing that exact same step here for problem 22. Well, first I'm going to write this whole thing out, I guess, because it didn't save. X minus 6, x minus 2 is equal to 4 over x minus 6, x minus 2. Since we have x minus 6 times x minus 2, they're going to cancel because I'm going to multiply x minus 6 and x minus 2 to both sides. So it'll be x minus 6 and x minus 2 to both sides. Top and bottom, so they're both there. They end up canceling. So then what you're left with is just now the top. Alright, and I'm going to just shift that over here. Zoom out a bit. Change the color back to red. So that gives me width. I'm going to just combine like terms here, by the way, just so we can make this quick. Let's go with, so we have x squared. Negative 6 plus 8, that becomes negative 5x minus 2 is equal to 4. Yeah. Alright, zooming in here, and I'm going to subtract the 4, move it over, so that leaves me with x squared minus 5x minus 6 is equal to 0. Factor. When I factor it, it turns out to be x minus 6 times x plus 1 is equal to 0. So that means x is equal to 6, x is equal to negative 1. But what happened to my extraneous? Remember, my extraneous x cannot equal 6. We have a 6 here, so it's called an extraneous. But negative 1 will be the solution. Alright, and that completes problem 22. Oh no, it's going to probably reset again. Actually, no, now it's just all black. Interesting. Interesting. I wonder if I change the page. Okay, now I'm going to just close out. Oh, my battery's running low. Okay, I'll finish it quick. Open it up again. Sorry guys, I was not expecting for 1.0 to be my functioning so much. Okay, either way, we're almost done. Solve the following system of equations. There's two ways to solve this type of problem, but to always guarantee it, we graph it. So we graph y equals 108 over x. So we graph 108 divided by x. Hit enter. It's not there. Reason why it's not there is because it's very high up. The next graph is 3x. So we go to menu, graph entry function, and we're gonna graph 3x. We see that line, but we don't see the other line. Why? So let's just zoom out. So zoom out again. Oh, see, so we start to see it. There you go, way better off. So then the answer here, whoa, my bad. So the answer here is the x-intercepts. These two will be the x-intercepts. So we go to menu, analyze graph, intersection. I clicked the inflection by accident. Intersection. So we graph them. One of the answers is 6, positive 18. Intersection. And the other one will be -6, -18. These two will be the answer. These 2 points. So let's say I graph it, and then it was the intersections. So my answer was -6, -18, and +6, +18. Alright, so I guess that'll be it for, oh no, my bad, I jumped the gun. We still have one more problem. So that's it for problem 23, -6, -18, and 6 and 18. Last one. 24. Determine the horizontal asymptote and vertical asymptote. Based off of this, there's 2 ways of looking at it. Vertical means up and down. So what graph do they not go into? You see here, they're gonna be getting closer and closer to that graph. Vertical always has to be as x equals. So this is x equals, this is y equals. I'll make a y more noticeable. Y equals. So my horizontal would be x is equal to -3. Well, scratch that. My vertical. And then my horizontal will be y is equal to, well, y value do they never cross? They never cross +1. So it'll be +1. And there you go. The algebraic way would be, luckily they gave us the function. We're given x minus 2, it's over to x plus 3. Vertical asymptote means it's located in the bottom. We set that equal to 0. So if we do x plus 3 is equal to 0, solve for it, x equals -3. Simple. Hence vertical asymptote. Horizontal asymptote. That's when we look at the degrees. This is 1, that's 1. So therefore, if you remember the rules, if your top is bigger than the bottom, your horizontal asymptote does not exist. If your top is equal to your bottom, that is when we do the leading coefficient over leading coefficient. And if we have the top is less than the bottom, that means y will always equal 0. Here, since they are the same degree, same exponent, we look at the coefficients. Leading coefficient is 1. The leading coefficient is 1. So what is 1 over 1? That is equal to 1. Hence, that horizontal asymptote. Alright. Just wait a moment, and that completes this problem, and I believe one more for KC8. Yes, one more problem. Okay. Determine the location of any holes, which you guys will probably make fun of me for this, and a vertical asymptote in the given function, or also known as removable discontinuity. Okay. A removable discontinuity means that you were able to remove the object. What could be removed here? Or in other words, what could be canceled? Oh, okay then, my bad. Sorry about that. We are back. So we left off with what could be taken out, Well, we have the x plus 2's could be taken out. Since it was taken out, that makes it to be a removable discontinuity. So x plus 2 was 1. But we have to set it equal to 0. Solve for x, so x is equal to negative 2. So this becomes the removable discontinuity. And what was left with? Well, we're left with x minus 3. So we're x minus 5. Vertical asymptote is located in the bottom. So we set that equal to 0 and solve for x. So x is equal to negative 5. So your vertical asymptote is at x equals negative 5. So that is your vertical. So alright, and I guess that'll be it for KC8. And time to pause this.